Andrew Quitmeyer. Welcome.
Howdy, everybody. I just wanted to thank you for having me here. And a lot of these great talks are very similar themes to what I do about making stuff, setting up lab spaces, using interesting, weird materials, and even making mobile buildings and place maker spaces that go around with you. But I also wanted to just mention really quickly, it's cool to be back here because actually 10 years ago, I was a 英文老师在Yan Tian. And one of my students actually came to Maker Faire today. So it was awesome. He was 12 and now he's 22. He's so much bigger. So it was really cool getting to come back to Shenzhen and see how much it's changed, and it's a special, amazing place. But first, I'm going to tell you about some of the weird stuff I do in the jungle. And I go quick, and we're going to talk about a lot of different strange things. So everybody, take a nice deep breath. Just breathe with me. Okay, and we're going to venture into the world of two very special things that are in my research. These things are creatures and computers. And they're both very interesting and special because they are some of the only things in the entire universe that can sense things happening in the world, and they can also react back to the world. They can make things change. They can move around. They can make sounds and light. And both these natural systems, as well as digital systems that we create with computers, express these types of behaviors. And what's really cool is when we put these computers and creatures together, it kind of helps us understand the design of each other. With computers, we know exactly how they're designed. We know what the programs are doing. And the challenges for us are how do we make them more interesting, more powerful, more able to adapt to environments. On the other side, you have creatures. We don't know how they're programmed. We don't know why they do what they do. And so we have to try to figure this out. And what's cool is we can try to use computers that can do behaviors with the creatures to try to put all these different components together about their environment, about our tools that we use with them, and all these interactions that happen. The problem is we don't exactly know what to do with all of our new fancy tools yet. And so we have to experiment and play around a lot with all of these different types of creatures and computers combinations. And I propose that we do this in the wild with the animals themselves. So hi, I'm Andy. I'm currently a professor at the National University of Singapore, and I'd like to tell you about making art and technology for biologists, with the biologists, and doing it as much as we can in the wild, in the field sites where their animals are actually living. And some people think that's a little bit of a crazy idea, but it's actually working out kind of cool. So my background, the reason why I'm doing this, I got started working with tracking ants in a robotics laboratory. We could use computer vision to try to monitor where the ants are moving, and know if Sally the ant's talking to Susie the ant, or what ants are talking to what. And it was really cool. We would sit in the lab and we'd write these computer programs all day, and it would work really awesome in the laboratory. We could know all these ants and who they're chatting with and where they're going. The problem is, once we bring this technology out into the field, out into the jungle, what does it do? It breaks. It does not work at all. So it can be awesome in the laboratory, totally failing outside. And I felt bad. I felt like I was failing these field biologists who want to be outside, exploring, seeing how their animals react in the natural world together. And I felt like I was forcing these field biologists and moving them into the laboratory. And come on, they want to be out running around with the jungle and not, stuck inside a laboratory all day. And so I started off by studying ancient kind of naturalists and people who did their experiments out in the wild with animals in their own environment instead of putting animals inside specific laboratory spaces that were much more controlled. And there's benefits to both types of science. There's a lot of things you can learn in the laboratory that you can't learn in the field, but I'm trying to make sure that people also bring technology and harness a lot of the abilities that we can learn about only in the field that we can't do in the laboratory. And so I started off my research during my PhD by joining some of these tropical jungle field stations. This is kind of like it looks like a James Bond supervillain hideout. There's like scientists going around in these jungle laboratories exploring all kinds of stuff. But they're incredibly nice, and they all have to work together in really strange places in kind of makeshift laboratories underneath houses in the jungle, and they create really weird things because their animals have very specific problems for them to address. For instance, I have one researcher that I worked with, and she needed a special thing that could hold a single tadpole in order for her to do experiments with a tadpole. And this isn't something you can go buy at Walmart or something like that. It has to be custom created, so lots of very specialized things. And so I started working with some of these scientists, and we would build new technology to let them play with different kinds of creatures. So this is my friend. He really likes experimenting with ants. His name's Peter Marting, and he wants to see what happens to the ants who live in these trees if you start smacking on their tree. And so he made this robotic ant tree smacker, and it's supposed to simulate something like a sloth climbing up the tree and trying to eat all the leaves from the tree, which really angers the ants who are in the tree. But he needs a calibrated way to tap on this tree for his scientific process. And so he moves back and forth. He brings something out to the field. It breaks. He brings it to the laboratory, tests it out in the field. It breaks again, and so on. And so these scientists are working in the field, but they're having to move back and forth to the laboratory in the field, and losing a lot of time every time their tools break. And so then we started thinking, well, what if it's the laboratory that needs to change and not the scientists? What if we can move the whole laboratory completely into the field itself? So then we started doing experiments and research with things that we called hiking hacks. So the way that these hiking hacks worked is we would hike out into kind of a remote wilderness somewhere, carrying all the tools from our makerspace. The very first one we did of these, we carried way too many tools. I was just like dying out in the field. We had to actually abandon some of our tools. We had to dig a hole in the middle of the jungle and bury them underground, and then come back a couple weeks later to retrieve them. It was not good, but we've gotten better at it. But so we would carry all the tools that we have, and we would live and work and design different kinds of scientific or artistic or exploratory tools with the scientists while reflecting on these amazing natural ecosystems that we could walk around in. And importantly, we would do lots of documenting and openly sharing all the designs that we're working with so that we can help other scientists and other technologists in the future keep working on the work that we find. We've done lots of these hiking hacks together in places like Panama, Madagascar, the US, Philippines. And while they pose lots of different interesting challenges, I'm sure many of you may have been in makerspaces, but maybe your makerspace wasn't taken over by army ants who started chewing on all your electronics, or suddenly everything floods and you have to like dry out all of your electronics in there. Though sometimes it happens in regular makerspaces too. But there's lots of cool, interesting things that we could do very rapidly. So we started doing fun projects like testing out early prototypes of ant sensors, and then what kind of display do you use for a sensor that's a bunch of different traffic points all over a tree? We used our tongue in order to kind of feel ambiently all these ants moving around a tree. We would make different types of behavior probes and see what kinds of creatures react to it, and we'd make things like firefly suits. Very simple. You program it to the same flashing pattern as a firefly, but then they can actually talk back to you. So you can blink, and then this firefly will actually blink back at you if you hit the right frequencies that you're flashing it. It's actually a mating ritual, and so when you're flashing at the firefly, they're like, oh, hey, you're looking pretty good. But we do other things. This is my friend Hannah Perner Wilson. She makes things with natural materials and electronics. So this is leaf headphones. They're actually made out of leaves with electrical wires in them. And so while we're doing these projects, we have kind of simultaneous research about hiking hacks, thinking about how we can take the whole laboratory into a complete mobile or wearable studio that goes around with us. So Hannah and me started looking at our current workspaces and all the different ways that we use tools and furniture, and trying to think about how can we fit this all on our bodies? How do we organize all this different random stuff and tools and electronics you might have at your makerspace? And so she came up with lots of ideas. She's an awesome designer and made lots of different backpacks that quickly unfold and turn into like organizers or pegboards that you can use anywhere in the world, out in the wild. Things are important such as light and different work surfaces. So you could turn a tree into a standing desk. And what's cool about these types of mobile work surfaces is if you can do it in the jungle, you can do it anywhere. So we would set up quick maker spaces just in the middle of big art science events, kind of like Maker Faire down here. And we would walk around repairing people's tools that had broken throughout the day. One other thing, when you're in the jungle, the only thing that you can really rely on being there is you. If you're there, your body's also there. In theory. And so we really start thinking about how can you use your body as a tool? How can we extend tools that actually are wearable and always on you for playing with and experimenting and designing with different kinds of tools, such as a wearable hip work surface or a knee pad soldering station made with flame retardant material, so you can just quickly get that circuit fixed whenever you need it. Information is super important out in the field because you don't always have like internet connection. You just can't pull out your phone and remember, oh, what was the pin or what was the resistor color code for this specific device? And instead, you might want to wear the information. So you can get things like temporary tattoos on your body, or you can even get permanent tattoos. I have a ruler tattooed on my finger so I can measure things in the field if I ever need to, super quickly. Sometimes, despite my best efforts, you can't always carry your tools with you. And so we also look at mobile studios, so kind of like moving houses, moving buildings. So this is a project I had called the Boat Lab, and we were in the Philippines and designing a whole floating makerspace to help citizen scientists and the local community engage with this coral reef that was right off the shore. It was built by the community. It housed all kinds of different scientific instruments and different electronic instruments, as well as artistic and visual displays of the sensor data that we would collect. I also use, instead of building boats myself, I try to use existing boats. So I've been starting to do more sailing hacks where we turn ships into floating maker spaces themselves, and we experiment with old technology as well as very new cutting-edge technology. This is my friend Matthias, and he has this amazing device that lets you see dolphins talking to each other. It's a sonar camera we could play around with. This guy's named Doug Jackson, and he's really cool too. He's building an entire open source boat for scientists, and he's doing it in his backyard. And you can watch him on the internet while he builds each single part of this and shows you how to build this boat too yourself. So my most recent work is I wanted to take this to the really extreme side and start thinking about how I can make my own kind of field station, field laboratory. So we had this thing called the Digital Naturalism Conference. PowerPoint just died on me. Huh? It wants to go to the wild, exactly. It got jealous. We'll take the file and we'll bring it out in the jungle later. It'll be okay.
Okay. Maybe, I think the audience cannot wait to go to the QA session, right? Why don't we just get a QA session for now and then we go back to the slides?
Totally.
所以，我相信今天也是很多人为了来看我们这个野生的、野外的创客。现在我们开放一个问题，好吗？大家一定要积极的举手。哦，好，那位先生。
给我你们的问题 questions, problems.
Hey, Andrew. My name is Kenny. Thank you for your presentation. It's very impressive. And so I want to ask one question. I think a lot of people also want to ask it. how to participate in your activities or projects. It's very cool, so cool.
I will tell you in some of the slides that will appear
Great,
in just
great.
a second. Well, totally. There's a couple different ways that you can all participate. One thing is I host this thing called the Digital Naturalism Conference, which I'll show you a little bit about. But it is a big conference for field biologists, for artists, and technologists of all sorts. We had the first one in Thailand, and we built all kinds of amazing things. And it looks like we're going to have another one sometime next year. We don't know exactly where it is, but we're going to find out. So this is a really good question. And
Okay, so if the answer is on the slide, let's go back to the slide.
Okay, cool. Excellent question, leading me right into this. So hackers, biologists, and artists, we all invited them to come for a big conference that lasted 8 weeks. We rented out, we had almost 300 applications from people from every continent except Antarctica. There was no penguins who applied. And it lasted for about 8 weeks, and we had up to 45 simultaneously people there. We rented out this little island off of Thailand, a chunk of it, and we let people just build and collaborate between artists, scientists, and engineers of all sorts. So people were doing things like musicians. They were setting up maker spaces on the ship. They were testing out water quality and doing open source underwater robotics, as well as microscopy and sampling different types of bacteria and microbes around the wild. And even doing things like studying different animals that live in trees with things like homemade tree climbing robots. This is an artist named Michael Candy who just built a whole robot within a day that climbs up trees. It's amazing. As well as more traditional science, there was a monitor lizard that washed up on the shore, and one of the scientists was like, oh yeah, let's go check out what's inside of it. It was dead already, and she was really interested in seeing the insides. Like a good scientist, right? We also looked at things like 360-degree camera traps. So instead of regular camera traps, capturing the whole virtual reality kind of photosphere, and doing things like looking at traditional scientific techniques and also bringing in architects and designers to rethink scientific tools. So this is Huiying, and she is doing soil sampling, and another designer put together this backpack made from natural materials that they built in the forest to actually store and hold the soil samples, which was cool. So there was dozens and dozens of different projects, but it's all leading up to my biggest project yet. I kind of think I want to do this permanently. So I'm actually leaving my job, and I'm going to try to set up a field station fab lab somewhere in the world. We were looking at a bunch of different locations, but it looks like Panama most likely will work out. I used to do my research down in Panama, and they have buildings next to where all these scientists live, and I kind of want to figure out a way to get it and make a jungle makerspace. So how can you get involved was the question earlier. One thing is Dynacon 2, the Digital Naturalism Conference 2. We are going to host it sometime next year. Not exactly sure where, not exactly sure when, but if you're interested, you can get on our mailing list. Just go to dynacon.org/apply. Also, if you're interested and just have a lot of money and want to help me buy a big jungle house, definitely let me know. That'll be great. But if you don't, the most important thing, I think, is to go play outside. Next time any of you are working on any kind of art or craft or electronics project, take your project and just bring it outside. Go to a nearby park, go to a natural area, go camping for the weekend, and try to do your project outside. It might be a little bit harder, but it won't be as hard as you think it is. And while you're building things, you're going to start noticing lots of things that you don't know about nature. You're going to be surprised. Things are going to be neat and interesting. There's going to be animals that you didn't notice before. So if anything, if you want to get involved, go play outside and go build outside. So kind of in conclusion, my goal is for these kinds of digital naturalists wandering around through jungles, building things to help them explore and understand and connect with all the different living creatures and amazing natural phenomena in lots of different ways. So thank you very much, and let's have some more questions if you got them. Yeah. Oh, thanks. Awesome. Electric unicycles, that sounds like a great idea.
So we use electric unicycles for commute, and when I come to Shenzhen, I use those also.
I see them a lot, yeah.
Yeah. So it's a big amount of battery in there, and you can actually use it to charge your other stuff. So we've been charging our drone batteries out of that, and for normal commute.
That's terrific. That's a great idea. A lot of people always ask me about like power. How are you powering all these electronics out there? And there's lots of good, different, fun hacks, but I haven't even heard the electric unicycle hack yet. So thank you very much.
如果没有更多的问题，那我们就放过 Andrew 啊，好吗？好 ，Thank you，Thank you Andrew.
Okay.
Oh, you guys have okay. One more.
这个问题稍微有点严肃，有点认真啊。就是我一直在思考一个问题，就是像那些贫困的山区，还有一些落后的一些地区，他们是否有这些可能性？因为他们不像我们深圳，那些创业空间，它有一些大型的设备啊，然后还有一些电子产品啊，然后他们是否也有可能就是因地制宜，就地取材，然后根据他们的自身地方的一些条件，然后呢，通过他们这些材料来解决他们当地的一些问题呢？这是我的问题，谢谢。
Sure. Cool, good question. So one thing that we end up collaborating with different people from like impoverished communities that have lacks of resources, because the design challenges tend to be very similar. If we're going in the jungle to study these animals, we also have very limited resources. So some of the things that we're working with and figuring out like how do I get light and work surfaces for building things is also similarly difficult. There's a really great young researcher named Jake Sana, and he's from a refugee camp in Africa. And so they're very limited in the resources that they're able to use. And he's building mobile studios to carry around to let people who have all these different skills be able to use their skills, even though they might not have electricity and things like that. So it's very harmonious kinds of connections between two different types of people working on different challenges, but the kind of core challenges end up being very similar. So it fosters lots of good collaborations between those.
Thank you.
How? Thank you, Andrew. Please have a seat.